Hello friends, in previous video we have discussed about the electrode potential, measurement of electrode potential and electrochemical series. Now we'll discuss about the Nernst equation. What is Nernst equation? Actually this is the equation which relates the electrode potential of any single electrode or cell potential of a galvanic cell with standard electrode potential, temperature and concentration of the species involved in a reaction. Is it clear? First we'll discuss about the Nernst equation for a single electrode. That for single electrode, the electrode reaction can be written in the reduction form like this. Mn plus aqueous plus an electron converts into M solid. This is the reduction reaction. Now for this, electrode potential at any concentration measured with respect to SHE can be represented like this. This is the electrode potential at any concentration. This is standard electrode potential. This is RT divided by NF ln concentration of product divided by concentration of reactant. Is it clear? Now in this case we can say R. This R is a gas constant. Its value is 8.314 joule per Kelvin per mole. F is a Faraday constant and its value is 96,487 coulomb per mole. T is temperature which is expressed in Kelvin, and this term represent the concentration of the species Mn plus. In a simple way, if any species is put in a square bracket, it represents the concentration of that species. Okay. Now, in the 11th standard, we have discussed that it's concentration of solid substance and pure liquid is taken as a unity. That's why this reaction becomes like this. Okay. Now, in this case, this ln is a natural logarithm, but generally we use the logarithm in the base of 10, and when this natural log is converted into the base of 10, then this is multiplied by 2.303. Okay, then if we substitute the value of R, F and T take as a 298 Kelvin, then our equation is this is the electrode potential at any concentration. This is standard electrode potential, and this will come when we put the value of R at 0.314, T is 298 Kelvin, and F is 96,487, and this ln is converted into the log, that is it is multiplied by 2.303, then this equation will come. One thing you have to remember, in this case we are using this symbol or sign is minus, then always put the concentration of product in the numerator and concentration of a reactant in the denominator. Okay, this is the Nernst equation for single electrode. Now we'll discuss the Nernst equation for galvanic cell, and we will take the first simple example, Daniell cell. We already discussed this is the reaction taking place in the Daniell cell. Zn solid plus Cu2 plus aqueous gives Zn2 plus aqueous plus Cu solid. And as we know, in this case, this is the reaction Cu2 plus 2 electron. It is taking place at a cathode, and this is called reduction half cell reaction. And Zn convert into Zn2 plus. This is the oxidation half cell reaction. This is taking at anode. Now we'll write the Nernst equation for each electrode, that is for cathode. Again we have written that is this is electrode potential of the copper electrode at any concentration. This is the standard electrode potential of copper minus RT divided by 2. Why this is 2? Because in this reaction these 2 electrons are taken by Cu2 plus ion and 2 electrons are loosed by the zinc. That's why we'll take as a 2 number of electrons. Okay, and this is ln 1 by C concentration of copper ion. This is for this copper electrode. Now for anode is our zinc electrode. Again zinc electrode will write the same reaction, but again we have to remember for the zinc electrode reaction is oxidation, but when we write the Nernst equation for the zinc electrode, we will consider it as a reduction process. Then in this case again this is like the similar copper, concentration of zinc ion will come in the denominator. Now we will find out the cell potential for the galvanic cell or this Daniell cell. We already discussed that this is cell potential is E cell E right minus E left, where E right is cathode and left is anode, and right side is the copper electrode, left hand side is the zinc electrode. Put the value of these. This is the value for copper electrode and this is for zinc electrode. Now in this case, this term is the standard electrode potential for copper and this one is the standard electrode potential for zinc. And if we take the minus of these two, we will get the E standard cell. Is it clear? E standard cell. And in the remaining term, we will get the RT by 2F is common and we will get this one. These are in the logarithm form. This is negative. This is negative. Okay, that's why this is ln negative. This will reverse of this will come in the down. That's why Zn2 plus concentration will come in the numerator. I think, is it clear to you? So this is the our reaction for Daniell cell for determination of the cell potential at any concentration. Okay. Now again, if we convert the natural log into the basis of 10 and put the value of R, F, and if we take the temperature as 298 Kelvin and N is equal to 2, then this term will come 0.059. Our equation is E cell is equal to E standard cell minus 0.059 divided by 2 log Zn concentration of zinc ion divided by concentration of Cu2 plus. And again, remember in this case, these are the concentration like the expression for equilibrium constant. Remember, you in the 11th class you have discussed in equilibrium constant expression we write the concentration of product side in the numerator and concentration of reactant side in the denominator. Okay, now we take the one more example. If this nickel and silver electrodes are present in a galvanic cell, then net cell reaction is this. Net cell reaction is this. Ni is converting into Ni2 plus and Ag plus convert into the Ag solid. Now we can write the Nernst equation for this. Again, E cell is E standard cell minus RT by 2. Again 2. Why this is 2? Number of electrons gained and loosed by the species is 2. Okay. This is Ln. Now again see this Ni2 plus, this is coming in the product side and this is Ag plus, this is coming in the reactant side. Again this is the square. What is the, why is this square? This is the stoichiometry coefficient of this Ag2 plus. And if we put the value of R, temperature is 298 Kelvin and F is 96,487, then we will get this our final expression for the cell potential of this cell. Okay, in general, if we write the reaction in this, these are the reactants, these are the products and electrons are exchanging, where the small a, small b, small c and small d, these are the stoichiometry coefficients of the species represented by capital A, capital B, capital C and capital D respectively. Then we can write the Nernst equation. This is E cell is equal to E standard cell minus RT NF. Now this is ln Q. What is this Q? This is the reaction quotient. Reaction quotient. Again, remember in the 11th standard when we discuss about the equilibrium constant, reaction quotient is the ratio of the concentration of product to concentration of reactants when reaction is not at equilibrium. Okay, so we can write this. These are the concentrate product of the concentration of products divided by concentration of reactants. Each concentration term raised to the power equal to stoichiometry coefficient. Okay, and again if we put the value of R, T and F, we will get this 0.059 divided by N and log. Why log? Ln, when we convert into the basis of 10, this is multiplied by 2.303. Okay. Now we'll discuss equilibrium constant from Nernst equation. That means how can we relate the cell potential with the equilibrium constant. Now see, if Daniell cell is taking Daniell cell reaction is taking place like this. Is it clear? As the time passes, Okay, concentration of Zn2 plus. This term represents the concentration of Zn2 plus keeps on increasing because at the anode Zn is converting into Zn2 plus. But concentration of Cu2 plus keeps on decreasing because at the cathode side Cu2 plus is converting into Cu. Clear? At the same time, voltage of the cell keeps on decreasing. How can you explain this? As this reaction is taking place, voltage of the cell keeps on decreasing. Okay, you can see this equation again. Okay, now in this we can say actually if we correlate with E cell with the concentration of Zn2 plus and Cu2 plus, actually this is the log and this is the negative log. This is the negative log. It means as the Zn2 plus is increasing, E cell will decrease. Okay, at the same time Cu2 plus is a decrease, E cell will increase. Okay, so we can say at the same time voltage of the cell keeps on decreasing. Okay, because Zn2 plus is increasing and Cu2 plus is decreasing. And after some time, when there is a no change in the concentration of Zn2 plus and Cu2 plus, then we can say voltage becomes zero and the voltmeter reading becomes zero, and this indicates the state of equilibrium. Okay, and in this situation Nernst equation can be written as, that is, E cell is equal to 0. E cell is equal to 0, and this is the expression for E cell. E standard cell minus 0.059 divided by 2 log concentration of Zn2 plus divided by concentration of Cu2 plus. Then this can be written in this way. This is okay. But at equilibrium, we can say this expression, ratio of the Zn to concentration of Zn2 plus to Cu2 plus, this is equal to equilibrium constant. That's why we can say E standard cell is equal to 0.059 divided by 2 log Kc. Okay. And as we know, this is E standard cell. In the previous video, we have find out this is E right minus E left, and this will come to 1.10 volt. That's why this is equal to 1.10 volt. And from this, we can find out the value of Kc. This is log Kc is equal to, for the value of E standard cell, we will get this 37.288. And if we take the anti-log of this, we will get this 2 into 10 raised to the power 37. So we can say in this way we can relate the E standard cell to equilibrium constant. Clear? Now in general, if we are having any galvanic cell, then we can write this relationship. E standard cell is equal to 2.303 RT divided by NF log Kc. And if we put the value of R, temperature is 298 Kelvin and F is 96,487, then we will get this one. Remember this formula. This will be useful for the calculation purpose and to find out the value of equilibrium constant if E standard cell is given to us. Now next, electrochemical cell and Gibbs energy of the reaction. In the 11th standard, we have discussed about the Gibbs energy. Gibbs energy is the maximum energy which can be drawn from any system. Okay. Now we correlate this Gibbs energy with the E cell and with the equilibrium constant. Now, if the EM of the cell is E and NF is the amount of charge passed and delta G is the Gibbs energy of the reaction, then this is the relationship. Remember it. Delta G for the reaction is equal to minus NF E cell. Okay, but E cell is an intensive parameter. Again, intensive. What is the meaning of intensive? It means it not depend on the amount of matter. Okay, we just try to explain it. But this is delta G is an extensive property, depends on the amount of matter. Okay, depends on value of N. How this N? Now, if this change the N, if we change the N, value of delta G will be changed. See, for the reaction, if we write the reaction of Daniell cell in this way, then delta G will be this. In this case, the N, that is number of electrons transfer will 2. But if all the species are multiplied by 2, then we will get this one, 2Zn solid plus 2Cu2 plus aqueous. Use this. Then in this case, N becomes 4. N becomes 4. Now total number of electrons which are transferred, it will be 4. That's why the value of delta G depends on the N. That's why it is an extensive property. If the concentration of all the reactant species is unity, then we can say E cell is equal to E standard cell. If concentration is 1, then we can say this is a E cell, and then we can write this is delta G standard. Standard Gibbs energy is equal to minus NF standard E cell. Okay, you have to remember this formula. Now, this is the relationship between Gibbs energy and standard E cell. Now we can find out the relation between delta G and equilibrium constant. We already discussed this one. E naught cell is equal to 2 point, not this, we can find out this relationship from this one. From this one, that is E standard cell is equal to 2.303 RT by NF log Kc. Okay, in the previous we have discussed this one. Now from the, if we compare these two, then we will get this one. If you put the value of this, if you put the value of E standard cell, this value, then we will get this one. Is it clear? Remember this formula again. Delta G standard is equal to minus 2.303 RT log Kc. And if we write in the form of natural log, then this 2.303 will not come, and in place of log we use the word ln. Okay, so these are the some formulas, and in this formulas number of numericals are based, which we will discuss in the next video. Thank you.